Chapter 2, The Chemistry of Living Things, Screencast 1. Now, this chapter is going to focus primarily on chemistry, and it's a very, very broad term that we'll be looking at. We will be focusing primarily on that chemistry that's critical to human organism. So we won't be looking at all chemistry. Now, this first screencast will primarily be an overview of some very, very general chemical terms and things like that that are important as we move forward. As usual, we're starting off this chapter with what are the key concepts that you should be getting out of this particular chapter. So the first is this concept that when we talk about the natural world, two things are really critical. Okay? They consist of matter and energy. Another really important concept is how do atoms link and bond to form molecules. So the different types of bonding is really, really critical. Another thing that is a really key concept that's important for us to understand is the fact that water is critical. Water has some very unique properties and also within our body acts as a biological solvent. Now, we'll also be looking at some biological molecules, and things that are alive are capable to harness the energy found within these molecules that are typically not found in nature. We'll also be looking at the importance of carbon. Carbon is found in all four classes of organic molecules that will also be looked at in this particular chapter. Now, when we talk about chemistry, chemistry really is the study of matter and energy. Now, this is not a chemistry course, so we're going to have a very, very narrow focus on the chemistry that we are going to look at and focus primarily on the chemistry that is critical for human organisms. Now, matter is defined as anything that has mass and occupies space, and it is composed of elements. Now, one thing that's important, we cannot interchange the terms mass and weight. Weight is mass and the impact of gravity. So in space, you have no weight, but you still have mass. So that's an important concept to keep in mind. Now, energy is generally defined as the power to do work. Now, the first thing that we're going to kind of look at are elements. Now, elements are things that cannot be broken down to any simpler form. That's it. That's as small as they get. And generally, you've probably seen what's known as the periodic table. And this lists all known elements. Now, there all is basically a symbol, and that's generally one or two letters. Now, some of these letters are going to be based on other languages and not English, and that might explain why sodium is Na and not So or Sd. So that's something that you kind of want to keep in mind here. Now, the atomic number, that indicates the number of protons that are found in that particular element. Now, atomic mass, generally we're going to be looking at two types of subatomic particles. We'll be looking at protons and neutrons, and together they form the atomic mass. Now, the third particle are electrons. Electrons are basically weightless, and we don't consider them. Now, the other thing that's going to be important in an electrically neutral atom, remember, protons are going to be positively charged, neutrons are neutral, electrons are negatively charged. So in a neutral atom, you will have the same number of protons and electrons. So that's really important. So something you need to keep in mind there. Now here, let's take a look at three elements. The first is hydrogen, and hydrogen is the simplest of all, and it consists of simply one proton. Now, let's take a look at oxygen. Now, we're looking at elemental oxygen and not molecular oxygen. So notice something. We've got 8 protons, 8 neutrons, and 8 electrons. And the electrons are distributed in 2 shells around the nucleus. The nucleus of the atom is made up of protons and neutrons. And electrons will be hovering in the outer shell. Now, sodium, 11 protons and 11 neutrons make up the nucleus. And there's going to be 11 neutrons hovering around the nucleus in 3 shells. So keep in mind, when we talk about the atomic number, that's the number of protons. Atomic mass is going to be the number of protons and neutrons. And when we talk about electrons, they typically have no weight. Okay? But also remember, in a neutral atom, the number of protons and electrons are always equal. Now, isotopes, these are going to be elements that have a different number of neutrons. Now, all atoms of an element have the same number of protons. Isotopes are atoms of the same element that have a different number of neutrons. So because of this, they will have a different atomic mass. Remember, atomic mass is made up by the mass of protons and the mass of neutrons. Now, some isotopes are really important when we talk about medical science overall. Unstable isotopes are called radioisotopes. And radioisotopes are not stable, and they're going to give off energy in the form of radiation or particles. Now, there are some radioisotopes that are used commonly. You may have heard of carbon-14. That's actually used to date fossils. A lot of diagnostic imaging implies the use of radioisotopes if we look at many cancer treatments. Also, the power supply for implants such as cardiac pacemakers. So once again, these are isotopes for various elements. Now, the last thing we kind of want to talk about is this concept of free radicals. Now, in the next unit, our screencast, we're going to be talking a little bit more about electrons and the importance of electrons and how they contribute to the stability of a particular atom. Now, most stable atoms, all shells are filled, and all electrons are paired with another electron. Now, free radicals, these are atom or molecule with one or more unpaired electrons. Another term that you're going to hear for this is highly reactive species. Also, these are things that contribute to oxidative stress. They've been tied into cellular aging, and also they can have an issue and damage proteins and DNA.